This is the notebook that has a compass. I can't tell you how hard it is to find software that has a compass in it. It's almost impossible. Of course, I could use things that aren't an exact compass, but then it would be a little bit more confusing. So what we're doing right now is we're talking about the median of a triangle. So each of these lines right here is a median of the triangle. We made that by using perpendicular bisectors. So I want to talk about this word centroid. You're going to be asked this on the final. Find the centroid of a triangle. And the way that you find the centroid is you go from this spot, the middle of this segment, which is what a median means. So go from the middle to the opposite angle, or the opposite vertices. So if I make this whole line right here, from this point to this point, from the median point, I guess, to the vertice, that will be one of the two lines that you need to make. So let's go from, let me switch up the color here too. It's starting to get confusing. So if I go from here to here, that's the first line. From here to here, that's another line. And you'll notice if I go from here to here, they all, if I did it correctly here, let's move this line a little bit. They all meet up at the same point. And that point is called the centroid. What point is off? This point needs to be moved a little bit. No, what's off? Theoretically, they should all meet up at the same line. It's looking a little bit off of mine.
Is it actually crazy?
All right, so can everyone go ahead and circle or just draw a point at this point and say that is the centroid? So eventually you're going to be making note cards for the final. The one thing that you need to know, the centroid comes from medians. So if you think of centroid, think of middle to vertice. So you now have one of the questions that's going to be on the final. Find the centroid of this triangle. And you're going to say, okay, that means I'm going to find the, if I can spell middle correctly, find the middle of each of these segments. You know how to do that. And then draw that to the other vertice, the opposite vertice. So you now know how to find the centroid. Sergio.
What about this triangle?
That triangle, that's the median. That's the official median of a triangle.
But there's like 4 triangles in total. Does that mean something?
No, it doesn't mean anything. I mean, there's some interesting math happening there. Like, the question I could ask you is, are all 4 of these triangles an equal area?
No. Oh, probably. They all come from.
Yeah, there's a lot of room to explore. It's just we ran out of time. It's maybe something that we can do when we come back in January.
Yeah, we've got time. Yeah, we can come.
All right, so we now know how to find a centroid. Let's go to the next slide. All right, so this slide I'm going to be finding, let's come here to my calendar. We're going to find the Orthocenter. And it's probably one of the trickiest guys. Tricky. The Orthocenter comes from The Orthocenter comes from finding the altitude of triangles.
Wait, how do you? Wait, altitude's height.
Altitude, yeah, altitude. So we need to find the heights of the triangles, but the altitude is difficult to find. I should probably pause right now to show you a resource that's really helpful. It's definitely not Mathway. If you go to Math is Fun Constructions, just type in Math is Fun Constructions. This one will have every single construction I will ever go over. Well, I think almost all of them. Look, the first 2, perpendicular bisector and angle bisector. That was yesterday. Today, oh, this one actually isn't on here. Dang it. Well, that was a fail. It doesn't have, oh, it does have altitudes. Okay, whew. I was scared there for a sec. This is essentially what we're doing, and the videos are super short, it's very precise, something that you can add on your note card. Some altitudes are really easy to find. I'm going to pause right here. This altitude I consider to be easy to find because it's already inside the triangle. The next one is going to be a little bit harder to find. So the reason it's hard is because it's not on the triangle. You have to extend the line and then it comes off here. Almost every construction that you're going to be doing has a perpendicular bisector, so you'll get really good at doing those. All right, I'm going to pause it here. This right here is an altitude. What means it's creating a right triangle. This angle right here is a right angle. And then finally, if it does it's going to do the same thing again. Perpendicular bisector, here we go. And it's going to draw a point from the vertice, or a line from the vertice to that line. So those are the 3 different altitudes. That's what we're going to try to recreate right now. Here we go. So, draw a triangle. Make sure your triangle isn't too big and it isn't too small. Try to get the Goldilocks zone, a medium-sized triangle. I'm going to change mine to blue. Kind of draw the same triangle most of the time. You have another 10 seconds to finish making your triangle. All right. Does everyone have at least one acute angle? I think you have to be acute. If you have no obtuse angle, they're going to be a little bit harder for you. I have one obtuse angle, so I have one easy altitude. Yeah, it was kind of not the smartest question I could have asked you. The question I should have asked is, does anyone have an obtuse angle? If you have an obtuse angle, it'll be a little bit easier.
It's like the right triangle, but not quite there yet.
Okay, let's try practicing making an altitude then. So you're going to grab your compass, and you're going to put the metal end of the compass on a vertice. I'm going to extend my compass so that it goes beyond the other side. So here it's touching the other side length, the opposite side length, and make sure it's a little bit longer than that, just a tad. Everyone has that so far. You're raising your hand if you need to ask questions. Or, yeah. If yours is a right triangle, then you're going to have this. It's going to be pretty easy. It's going to come out basically to the other vertice. Okay, so it's slightly longer, and then you're going to go ahead and make tick marks that touch that line segment. So this line segment right here, tick mark right here, move it over, and there's going to be a tick mark right here. Those points that you have just created are going to be the new points that you're going to be using to make a perpendicular bisector. So this point right here and this point right here, we're going to use those points for a perpendicular bisector. So hopefully we're going to get lots and lots of practice. You'll be experts at perpendicular bisector, which means my metal end of the compass is going to start at one of those intersection points, and it doesn't matter the size of this again, so I can make sure that it's at least halfway. So I can see that this is at least halfway. And then I'm going to go ahead and make my perpendicular bisector. So I'm going to make a semicircle here and here, and then I'm going to move my compass over so the metal tip is over here. On my other point, I'll pause here. All I've done so far is I had my metal compass, or my metal end of the compass, and I drew 2 tick marks. I'm doing the perpendicular bisector. I'm now moving it over to the other intersection. Let's drag this over and make my other semicircles, my other kind of tick marks here. And I've now made a perpendicular bisector. So I move my ruler and I kind of make this line. And go ahead and extend this line. This line can be nice and long. Oh, sorry, I don't actually need that point. I'm sorry. I've kind of made a tiny mistake. I did too much work. This one I don't need. This one I do need. So make sure you have at least that one. So if I come back here, I don't really need this one. So let's get rid of it. I'm now going to make kind of an extended line that goes from our, let me just change the color here, from our vertice down through our intersection point. I'm going to make all my altitudes red. And make sure that line is extended. a nice long line from that vertex. What should have happened here is we should have a right angle right here if we did it correctly. If you don't have a right angle, something happened and it's bad. By the way, when I said we did too much work up here, that intersection point, whatever that was, it should still go through that line. I just kind of erased it because we didn't need it. Let's do the same thing where I have to extend a line. And you maybe had to extend a line to even get these 2 tick marks originally. So let's try another one. Again, I'm going to have my compass metal end on one of the vertices. And I'm going to go to the opposite line here and extend at least beyond that line. So this one is beyond the line. Notice what's happening here. I'm going to make this slightly smaller. Is when I make my intersection here. So if I make my little tick mark here, bless you, bless you. This is in black, good. When I make this intersection point, it doesn't come over here and intersect anything. If I come up here, nothing is happening. That's because I need to extend this line. So I'm going to kind of draw my line. It's off screen, so I wonder if I can hopefully zoom up. I need to extend this line. I guess I can drag everything. Can I just Command A and drag everything down? There we go. I need to extend this line in order for this arc to actually intersect something. So here I go. I'm going to extend this line. You just kind of cover it with your ruler, and you extend that line. I'm going to do it in a slightly different color. Let's use orange, sure. I'm going to extend this line, and now I can see the intersection. Again, these 2 points here and here are going to be my new points when I do a perpendicular bisector. That perpendicular bisector should go through this vertex if we're doing it correctly. So here we go. I'm now going to put my metal end of this compass on the intersection point. Make sure that it's at least halfway. Let me come down here. Make sure it's at least halfway, so a little bit like that. And then go ahead and make my semicircles there. Actually, I don't need that one. I only need the one that's farthest away. Or, it actually doesn't matter. I'm realizing it doesn't. You just need one or the other. So if I make one that's up here, that works. Because what's going to happen with one intersection is I'm going to come here with a line. Let's make this line red again. That's the correct size thickness. And from our vertex through that intersection point here and just continue it out onto it forever. What should have happened is, again, you should have had some sort of right angle. And you can see down here I do have a right angle right here. And that thickness is not quite what I wanted. There it is. Yes, Andres.
So there's going to be these types of questions on fun.
Yes,
And we're going to have to use these.
Yes. Yes. So the question that I'd ask on the final is find the orthocenter, and that's what we're doing right now. What I'm noticing also is that this line needs to be extended because nothing is intersecting yet. This line also needs to be extended. And then finally, I mean, we're basically done at this point. You found the orthocenter. There it is. It's up here outside of the triangle. Sometimes the orthocenter is not inside the triangle. But there's the orthocenter. We found it. If you want to check that that's the orthocenter, you can make another altitude. And just for the sake of practice, because we're basically done with today, go ahead and practice finding another altitude, which means I haven't used this vertex down here. So I need to extend this. Oh, no, wrong button. What's going on here? There we go. I need to extend this at least that long. Is that going to be too long? No, that's perfect. So I can come here and make my other. Oh, okay. Change the thickness of this line back to that. There's one intersection, and then there's going to be some intersection out here. Draw that. in the blank space. And again, I'm going to need to move everything down. I'm going to extend my blue line so that this semi-arc that I just drew intersects something. So I'll extend that with another, let's do an orange line. All right, again, the 2 points that I'm using, this point and this point, and I'm going to do the perpendicular bisector. So my perpendicular bisector is going to come right here, and I'm going to make this almost half.
Light reacts. That looks like flat reacts.
Oh man, I missed it. Should have been right there. Oh, this is not quite on the intersection. There we go. Extend that line. There's the intersection point. And therefore, if I draw my red line from our vertice through this intersection right here, yeah, they all intersect at the orthocenter. All right, so you now know how to do 2 things after today.
Find the orthocenter and find the median.
You can find the centroid of a triangle, and you can find the orthocenter. By the way, the centroid is kind of cool. The centroid is the point at which you can balance any 2-dimensional object. So if I get a piece of, well, any 2-dimensional triangle, I should say. If I have a triangle and I cut out any triangle out of paper and I find the centroid, I can put my finger on the centroid and I will perfectly balance that triangle. So think of the centroid as the center of balance. Your homework tonight, on a new piece of paper that's not on your notes, find the centroid and find the orthocenter of a triangle.
We'll think about it. I mean, yeah, we'll do it.
Because this needs to be on paper. I could do this on something that's called Geogebra,
Yes.
but then I'd have to teach this lesson a whole different way. I can show you what that looks like. Should I give you guys a preview of what it looks like on Geogebra? Because you guys are just hating the pens and papers. Is everyone okay? All right, so this is what it would look like on Geogebra. You guys would use the online version. I guess I could use it as well. I'm just not as used to it. This is what it would look like on Geogebra. Go, computer, go.
Mr. Smith, would you prefer that over this?
I kind of prefer the pen and paper in almost every scenario. So let's make Geogebra full size. All right, so this is what Geogebra looks like. I still need you guys paying attention. Say you have a triangle. This is how quickly you can make a triangle on Geogebra. Click, 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 click. There's your triangle. If you need to make a compass, you come over here to use the compass tool. So if I want my compass to be, I don't know, this entire length, that works. I can zoom out and put that compass around A. I can click on the compass again to copy the compass, put it around B. And I can find that these intersect at these 2 points here and here, and I can make those points. So I click on the point tool. That's a point, and I can make a line in between them. There is the perpendicular bisector of that point, which means that this point right here is the midpoint of AB. And you can do that same thing again. I can do the midpoint of CB. So again, I can make a compass, click, click around C, copy it by clicking on the circle around B. They should go in this red box that's over there. And then there should be a line that goes through that and that. And I have my point right here. I'm almost done, Andres. And then I'm going to do the same thing over here. I'm going to find... I'm still like teaching. This is still being recorded, guys. Yes.
Subscribe to Mr. Sindel.
Around A, copy the same size compass around C, and then you can find the intersection point here. And now it's getting confusing here and here. And we have a line and therefore we have our point. And you can turn these circles, oops, that's the wrong, I have to click correctly. You can turn these circles on and off also, which is the equivalent of erasing them. So if I hide all of these circles, it's really easy to see that I found all the midpoints. I can even turn off these lines as well. And I can turn off, I can like right click on G, I can say hide this, or unshow it, unshow it, unshow it, unshow it, unshow it, unshow it. And look, I found the median or the midpoints of each of these segments, which means it's really easy for me to do a line that goes from this midpoint here, this midpoint to the vertice, midpoint to the vertice. And you can say, oh, look, the centroid is right here. You found the centroid. So that's how quick that lesson could have been. Do you guys think that you would prefer doing it this way?
Maybe. Yes.
It's more confusing because you don't actually understand that like a compass is a physical thing.
Which one's easier?
Anyway, we'll talk about this more tomorrow.
Which
You guys are just